All right, boys, so today we're going to talk about titrations. Titration is an accurate way of neutralising a alkali and an acid, okay? So we've got a large amount of acid in this contraption, which is called a burette, okay? If you zoom in really close though, you can see there are graduations along the burette. If you zoom down, you can see we start at 0, and then as we go down, more and more and more, kind of like a measuring cylinder, but it's got a tap at the bottom, okay, which is really useful and super important. So what we're going to do is we are going to use this thing, which is a very, very fancy and expensive pipette, okay? This is super accurate compared to the slightly rubbish ones that we use normally in science lessons that are made of plastic. So we're going to use this pipette. And this little contraption is going to help us suck up the liquid that we need. So if you zoom in here, it says 25 millilitres, okay? And I'm going to suck up the sodium hydroxide all the way up here until it reaches this little really hard to see line, okay? And that will give me exactly 25 millilitres. Being exact is super important for titrations, okay? So I'm going to put it in. We're going to draw the liquid up. Oh no, I've got a bubble already. Sad times, hopefully it pops. This is the bit that takes forever. So that exacts it. I think I'm literally just on the meniscus and I'm going to transfer it to a conical flask. So now we know in this conical flask is exactly 25 millilitres of sodium hydroxide. And we know because of what's written on the beaker that its concentration is 0.1 molar. So it's 0.1. Not that strong concentration if you think about it. Okay. So now both of these liquids are clear, if you hadn't noticed. So how on earth are we going to know if this has reached a pH of 7? Well, we have this beautiful substance called phenolphthalein. 10 merits if you can remember how to spell it for the rest of your life. Okay, so this is an indicator. We're just going to add a few drops. We don't need a lot. Oh. So you can see in an alkali, it is pink. Okay, so what we're going to do, take our 25 millilitres, put it under the burette.
Why have you picked that one rather than universal, miss?
Well, it changes exactly at 7.
Oh, right.
So that's super useful, isn't it?
Okay, yeah.
So we don't care whether it's 8 or 9 or 10. We care if it's 7.
Gotcha.
You know? So now what we're going to do, we've got it on a white towel so we can see a really clear colour difference. So we're going to start to open this tap and we're going to drop the acid. Okay, so we start at 0 really slowly, so slowly. Suspense is killing me. And we're going to swirl it. Still pink. Oh, we've got a nice stream of drips here. Still pink, still pink, still pink. Got to keep your eyes on the prize. Still pink. This may take a while. Ba-bam! We have reached 7. So let's pan up. And you can see here the meniscus. And the bottom of the meniscus, if I can read it rightly backwards, which I can't. Can you read it, sir?
Yeah, it's just above So that's about 17.5.
17.5. So we need 17.5 millilitres of acid to neutralise 25 millilitres of 0.1 molar sodium hydroxide. Got the white tile, made it a lot easier for us to see the colour change. Sorted.
Right, boys, I would like to show you another way of looking at neutralisation, and it's really good because you can actually see the whole pH scale. So I've got this thing here, which is called a burette, and the burette is a very long piece of measuring equipment. It's very, very accurate, but we're not going to use it for that. We're just going to use it for mixing together, really. Now, in here, you can see bright red, must be an acid, and I'm just going to add a whole load of alkali to it. Now, this is a special alkali. And I won't get into the science of it too much, but it's got some it makes carbon dioxide as well. So it should go bubbly. So I'm just going to go on here. What's up, mate?
Danger! Danger! Using mystery substances too hard!
Say what? What?
Danger! No goggles, danger! Put it on the floor, sir.
Oh, you think I might tip it in my eyes?
I think you might tip it in your eyeballs.
Okay. All right, let's carefully move it. We'll move it to the floor.
Okay.
Right. Okay, this is a bit safer. So I've got the alkali. The alkali is ready to go, and it's just slightly bubbly alkali, really. So let's pop them in. We have got acid down there, and in goes a bit of alkali. And as you can see, it's bubbling, it all mixes up and it spins around a bit. And oh, you can see the colours. Can you see the blue there? The blue there showing us it's alkali. So we've got a slight range of things there. We have got acids and alkalis, and sort of somewhere in the middle here, we've got something slightly greeny. Let's put some more in. Right, add some more, and we're off again. So, again, up at the top, we've got the blues, we've got the alkalis up here, which is the alkali that went in the middle, we've got in between, we've got neutrals and stuff, and down the bottom, we've got all the acids. And they're nicer. Let's get some more in. Let's get some more in. And I'll just let that run. So this is pretty much your pH scale, really. Red's down the bottom. Where they're mixing, it's gone neutral. We're neutral along here, and then up here, alkali. And because it's bubbly, it all mixes together. If it didn't bubble, it wouldn't really mix. Take forever. Right, I'm just going to show you how to do some simple word equations for neutralisation reactions, and that just means whenever you get an alkali and you react it with an acid, what do you get? And we're just going to practice something like that. Now the simple answer to what I just said was alkali and acid is salt plus water. They turn into some sort of salt and some sort of water. I mean, they turn into water basically. So let's have a look, and I've colour coded these just to make them a little bit hopefully easier to understand. So the first one is sodium hydroxide. Now that's an alkali. Without doubt that's an alkali because it's got this word hydroxide there. Hydrochloric acid, that's an acid, you know, because it's got the word acid there. And it's going to turn into something called a salt, and it's sodium chloride in this case. And we're also going to get, the other thing we get is water. We always get water. And I've colour coded that blue just so we can see because water is blue. Now next one. Here's your alkali again, lithium hydroxide. It's got hydroxide in, and there's the one with the acid in, that's the acid. Lithium, well, if we look back at this, the one before, sodium chloride, it's followed up by the purple bit, which is the bit from the acid. So it is, again, it's just going to be chloride again, it's going to be sodium chloride. There we go, just like the previous one, and we always get water. Water is always there. Okay, following the same patterns, acid and alkali makes a salt plus water, so we always know there's always water. And potassium, well, it's hydrochloric acid again, it's chloric, so let's go there, potassium chloride. Now, the reason I've coloured these bits blue, hydroxide, that's hydrogen and oxygen, and the word acid. Acid means there is some hydrogen there, it's just a word you've just got to remember. If there's acid, there is hydrogen. So hydroxide, OH, and hydrogen, they go together to make water. Now that's the reason why I put these two as blue, and this is blue, and this is blue, is because those things go together to give water. Hydroxide is hydrogen and oxygen, acid means hydrogen and water. The famous formula for water is H2O, means hydrogens and oxygens. Now, the thing that's missing here is the red thing. Well, the red thing is the metal. It's the metal there, so that is sodium. And again, all I've done here is I've flipped them around. These are the same thing, it works the same way, but we've got the acid first, and we've got the alkali afterwards. Well, the blue things, the acid is hydrogen, hydroxide is more hydrogens and oxygens, so we're definitely going to get water. Doesn't matter, all we've done is flip them around, we can still get the same things. And the hydroxide and hydrogen, that's going to give us water, without doubt. And the thing that we're going to have here, what's going to come after that? Oh, it's the purple thing. It's the, well, the purple thing here in this case, it's sulfuric acid. It's made out of the acid stuff, so it's going to be, in this case, it will be sulfate. Sulfuric acid gives sulfate, nitric acid gives nitrate, hydrochloric acid gives chloride, and so on and so forth. So looking at this one here again, we've got nothing to go on here, so we always get a salt, and the salt is the bit of metal, it's the red bit, and also the bit that's come from the acid, so it's nitric acid, it's going to give us the nitrate, and we always get water. Calcium hydroxide. Okay, so I've taken all the colours off, but it just works in the same way. Calcium's your metal and your acid, hydrochloric, so that is going to be calcium chloride. Where's it gone? And the other thing we always get, we know, is always water. This one here, we've got potassium, 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 and then it's the thing that's come from the acid, so that's the nitric, potassium nitrate, and we always get water. Lithium hydroxide, nitric acid, well, it's got to be lithium nitrate plus water. And looking across here, it's gone mad, turn that off. Oh, and that's got something missing at the beginning. It's something hydroxide, so this is the alkali. Sulfuric acid. Okay, so if that's sulfuric, we're going to get sulfate. That there must be sulfate. Well, what goes here in the alkali? Well, it must be the metal. The metal here is potassium, so it must be working back that way, just flipping over to the other side. And we always get water. Same here. Here's one you've not met the name of, ammonium, but it's ammonium. We don't need to worry about what that becomes. It's got chloride in it, so it must be... yeah, it's got to have chlorine in. It's the hydrochloric. And ammonium, well, we know we get water. We know we always get water, don't we? What do all alkalis contain? All alkalis contain hydroxide, every time. So, there's three. I've done the colours on the first one. If you wanted to have a look at those, and maybe just give yourself a moment and just think, what would they be? Just, if you want to pause this and try and work them out. just work out what's on the left and do an arrow, and then what's on the right. Well, we should see that doesn't matter whether you start with the name of the alkali or the acid, it doesn't matter, but we're going to have these two things, hydrochloric acid and magnesium hydroxide. They're going to be over there on the left somewhere, over there on the left, somewhere there. Doesn't matter which way around. Then you've got to have your little arrow, meaning they change into. Now let's try and muddle those round. Well, we know we're going to get water. We're definitely going to get water there. And the other thing is going to be, well, it's got to have magnesium in. So it's going to have the word magnesium here. And it's got the word chloric there. So we're going to have chloride over here. So it's got to be magnesium chloride. Just see if you can do the other two. If you've not sorted those, just see if you can work out the other two. Just pause for a moment. Right, so these two on the left, either way round, doesn't matter, over there, flip around in some way. Then you've got your arrow, and then you've got the word lithium here, so you need lithium there, and you've got chloric over there, so it must be chloride, and then you always get water. And then lastly, these two are going to be on the left. Arrow changing into, you know you got water, and let's have a look. So we've got the metal that's in here is magnesium, and oh, that's one we haven't seen before actually, isn't it? Where instead of hydrochloric, that's hydrofluoric, so it's actually going to be fluoride, magnesium fluoride, plus little plus sign there. Alright, now if you didn't follow that, I did go through it very, very quickly. If you want to go back through it and just go through it and pause it each time and just have a look and try and test yourself on those. Plenty to go through. Alright, thank you. Cheers.